Right. Thank you, Rico. So we will start our joint class for today. We will open it with an opening prayer. Dr. Vera, can you help to open with a prayer?
Oke, Dr. Rusia. Bismillahirrahmanirrahim. Allahumma sholli ala Sayyidina Muhammad wa ala ali Sayyidina Muhammad. Allahumma ighfir li dhunubi wal walidayya warhamhum kama rabbayani shighara. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma warzuqni fahma.
Thank you, Dr. Vera. Okay, so our agenda for today, we will first we will make a summarize about module A1. I believe that all of you have done working on module A1. So this time today, we will make a summary about the module. And after that, we will continue with module A2. After we explain briefly about module A2, then you will work in group. Perhaps you still remember what Dr. Fabian has mentioned in the previous class. We will continue with the FT this week, but the plan changes since there is several things going on. So Dr. Fabian now is in Osaka University. For the last week, he works from Monday to Sunday without any rest. Beliau bekerja dari Senin sampai dengan Ahad, Minggu, tanpa ada istirahat. That's why he's exhausted because of a lot of activities that he's doing. So unfortunately, he cannot join us today. Karena itu beliau tidak dapat bergabung dengan kita hari ini. Karena itu, the topic, the continuation about DFT will be discussed later, not in the class today. So today we will make a summary about module A1 and then we will continue working on module A2 and you will work in group. Okay, so before we start, let us take picture together. Nabila, are you ready?
Yes, but I apologize. I am not able to turn on the camera for today, Dr. Lucia.
Okay. The other, can you turn on the camera so we can take picture? Fatin, Alexander, and Mentari. Can you turn on the camera so we can take picture? Thank you, Fatin. Alexander and Mentari, are you able to turn on the camera? Okay, let's proceed taking the picture, Nabila.
Okay.
Thank you, Mentari.
Okay. Say cheese. 1, 2, 3. Wait a second. I can capture this. Wait, Dr. Lucia, it's still open. Okay, one more, please. Say cheese. 1, 2, 3. Oh, wait. You closed your eyes? One more, please. 1, 2, 3. Okay.
Right, thank you, Nabila.
Yeah.
Okay,
You're right.
so let us start. We will give you the summary about A1. Dr. Vera, are you ready?
Yes, I'm ready.
Okay, the
Can
time.
you hear my voice clearly?
I can hear you clearly.
Okay, thank you. I will share my screen. Dr. Lucia, can you see my screen now?
Yes, I can see it, Dr. Vera.
Okay, I'm going to start. Assalamualaikum warahmatullahi wabarakatuh. So today I would like to give you a quick review of what we have learned in Module A1, especially atomic ground state. I hope that you have at least calculate the exercise, doing the exercise or discuss with your team in your groups, or at least you read the exercise, the Module A1. Have you discussed with your teams? Not yet? How about calculations? Calculation. How about student in UTM and also in Unsud?
I think they have started.
They're started. Okay. So, yeah, I'm going to continue. So, first, we have to know about the objective of the Module A1. The first is distinguish the physical and computational problem. So here's the cognitive. C22 is the cognitive, number 2, and also the dimensions. And the second objective would be check the validity of the FT calculation with hand rules. So maybe you will ask why we start from atomic ground state. In the previous class, Dr. Fabian shows us that the FT is really good for many electron systems. But before we use our knife, before we use our tools, before we use the FT, we have to check first whether it is good for atomic or not. And if we convinced enough that the FT is good for atomic system, then we can continue to molecule system, the bigger system, and also for the bigger system like for surface or another system that is more complicated. That's why the Module A1, we start from the atomic ground state. Okay, and we start from the analogy about the FT and the car. In here, have you ever seen the mosquito's coil? Yeah. Because we live in the different era. So maybe for Dr. Lucia and also for Dr. Matt, yeah, they really know about the mosquito coils, but I'm not sure about you guys. So this is special for you. I took the picture from the Google, so you have to know. So after this class, there is no one that they don't know about the mosquito coil. So we start from the analogy from the FT and a car. In here, we claim that we want to be an expert user, not the one that doing for algorithm or so on, but we want to be an expert user of the FT. So the analogy is, if the analogy is a car, so if we want to be an expert user, the analogy will be, we want to be an expert driver. So if we want to be an expert driver, here we have to pay attention of 3 aspects. The first aspect is knowledge. The second aspect is rule. And the third aspect is experience. So normally we start from knowledge. So we have to know about many things about the car. And then after we know about the car, we learn about the rules. So, and then after we know about the rule, we have to practice to drive the car, and so we have the experience. That's the normal things. But in here, we start from the experience. So that's why we start from module A1. So you know, or you learn that before you know the FT, you can do the exercise in module A1. You can calculate in module A1, even before Dr. Fabian tells you about the FT. That's why I think this is the best method for us if we want to be an expert user. So we start from the experience. So from module A1, you do a lot of calculations. So you have to gain your skill here for calculation. And then you learn about the rules, about the hands rules, or if you are to be a driver, you have to learn to drive a car first. Or maybe you have a motorcycle. If you don't have a car, no, maybe you can use the analogy for the motorcycle. So you learn how to drive motorcycles. But you know, where's the gas, where's the pedal, where's the, yeah, everything. And then you learn about the rules. So if there is a traffic light, what should you do if the light is red or yellow or green? You have to know that. Yeah, there is a certain rule in the road that you have to learn. And after that, you because you gain a lot of experience and then you gain a rule, you have knowledge. So we build knowledge based on experience and rules. So we start from experience and then rules and then knowledge, and that's become the bigger and bigger, and you become an expert user. So we choose to start from the experience, not from the knowledge. So that's why you can use the FT even though you never take like quantum physics class or the FT class before. So here's the analogy. If we using a car, the more we drive, the more our skill improve. And then the more our understanding of traffic signs increases. And the more our knowledge about the car itself increases. Because we don't want to be a mechanic, we just want to be an expert user. And for using the FT, the more we use the FT, the more our DFT skill improve. Like now your skill are, I think, improve because you, in module A1, you learn how to make an input file. Like how many input file that will you make? Yeah. And then you learn about reading the output file and then tabulate the data. Yeah. Maybe now you can do it with your closed eyes. I mean, closed eyes is do it. Just like maybe Dr. Mark and Dr. Lucia, they're so expert, so they just win by closing their eyes. And then the more, and then the second one, the more our understanding of the FT rules on various system increases. Like now we learn about the Hans rules. So you don't learn from quantum physics. So actually we know about Hans rules in the introduction of quantum physics from the Griffiths books. But now we learn from the FT first. We calculate first, and then we check on the Hans rule. So we learn about the Hans rules. So, and in the end, we will get the more our knowledge about the FT itself increases. So, do you understand about this analogy? Okay, thank you. And then this is our workflow. So when you read the exercise, when you read the instructions, we will have 3 steps. First is calculations, and then the second is tabulations, and the third is analysis. Jadi yang pertama akan ada 3 step yang kalian pelajari saat kalian membaca contoh soalnya. Yang pertama adalah kalkulasi, jadi kita kalkulasi dulu, kemudian setelah itu kita lihat hasilnya dan kita tabulasi, dan yang terakhir kita menganalisis hasil yang kita tabulasi. So we are going to the first step, the calculation step. In Module A1, we only learn about single point energy calculation. We do this calculation for some atoms, right? Like hydrogen, heliums, and so on. So only one type of calculations that you learn in Module A1. But you have to learn like abundance atom, and then you have to tabulate. So just be patient in Module A1 because you have to have a lot of experience. You have to have a lot of practice here. So that's why. And in the single point energy calculation, we use 6 variation of method. So you will have 6 combination of exchange correlations and basis set. We use 2 exchange correlation, right? And then 3 kind of basis set. And then you combine it. So we have 6 combinations. But the calculation is only single point energy calculation. But we do it for a lot of atoms here. This is for exercise A1 until I think A6. You only do the single point energy calculations. Jadi kalkulasi yang kita lakukan hanya kalkulasi single point energy. Tapi kita menggunakan kalkulasi ini dengan 6 variasi metode. Nah, 6 variasi metode ini kan kombinasi dari 3 basis set dengan 2 exchange correlation. Nah, ada 6 kombinasi yang kalian lakukan. Jadi sepanjang exercise 1 sampai 6 cuman 1 macam kalkulasi saja. Cuman jenis atomnya yang banyak. Ya memang kalian butuh banyak latihan kan supaya bisa kalkulasi dengan mata tertutup deh. Okay. And we learn about the calculation technique for restricted and unrestricted method in open shell models. For example, oxygen atom in triplet state. This is in exercise 2. So by default, the Gaussians will do the restricted calculations, restricted for closed cell, and then unrestricted for open cell. So what is the difference between the open and the closed shell model? The difference is we use the open shell model if there is unpaired electron. So for example, the number electron is odd. So there is maybe 1 electron that is not paired. So we have to use the Gaussian will automatically use unrestricted for the open cell because there is 1 electron that is not paired. For the for the closed cell model, they will use restricted. Jadi ada 2 teknik kalkulasi. Yang pertama restricted, yang kedua unrestricted. Jadi kalau secara otomatis, by default, Gaussian itu akan mengkalkulasi restricted untuk sistem-sistem yang dia closed cell. Jadi semua elektronnya berpasangan. Tapi kalau yang open cell, dia pakai unrestricted. Karena ada elektron yang tidak berpasangan. So, what is the example of the open cell model? For example, in the doublet state or in the triplet spin state. In the doublet spin state, there is one electron that is not paired. But in the triplet state, you will have two electrons that is not paired. Yeah. But in exercise 2, you have to calculate. From your calculation, you got the oxygen atom. The lowest energy would be the triplet spin state. So Gaussian will automatically calculate the oxygen atom using unrestricted method. But you force it to calculate the oxygen atom using restricted. Yeah. So in the unrestricted, we will calculate the alpha orbital first and then the beta. But in the restricted, you force them to be one room. You will see the difference when you visualize the atomic orbital or the diagram, the energy level diagram of atomic orbital. And then we continue for the second step is the tabulations. So the purpose of tabulation is organize the data for further analysis. So that's why in the previous class, you learn about how to make, in the module A1, you learn about how to make a good table or make a good tabulations. And what should be tabulated? At the first, you need to tabulate the electronic energy. This is task in the exercise 1 to exercise 4. And then the second one is orbital atomic energy. This start from exercise 2. Yeah. If you don't believe me, you can check the module A1. Okay. And then the third one will be the energy difference between our calculations and experimental data. And the fourth is valence electron configurations. So why we need to tabulate energy difference between our calculation and experimental data? Any idea? Sorry? Validated data? Confirm? Yeah, we need to check like the accuracy. Yeah. And then valence electron configurate. So you can validate your calculation result with the Hans rule. Yeah, that's our second objective for module A1. And then the fifth will be job CPU time in the exercise 5. Okay, and then next is, the next step will be analysis. What to analyze? First, we compare our calculation data between two different spin state. Yeah, the lowest spin state. Like for example, you compare the singlet with the triplet spin state or doublet with quartet. And the second, you compare among the method. Maybe you see, you compare the Hartree-Fock method with B3LYP method. And also, you can compare about the 3 basis sets. Jadi kita bisa membandingkan hasil kalkulasi kita. Jadi antar hasil kalkulasi kita bisa membandingkan. Yang pertama, yang butuh kita bandingkan adalah 2 spin state yang berbeda. Jadi kita membandingkan spin state triplet dengan singlet atau doublet dengan quartet. Terus kita cari mana yang energinya paling rendah. Itu kan kita membandingkan. Terus kemudian yang kedua, kita bisa membandingkan antara exchange correlation atau antara metode Hartree-Fock dan juga B3LYP. Jadi kira-kira apa pengaruhnya pada energi. Kemudian kita bisa membandingkan juga dengan antar basis set. Bisa mengikuti? Okay, and then the second, we compare our calculation data with experimental data. Why we need to compare our calculation data with experimental data? Because we have to know about the accuracy of our model. So, how much the accuracy if we use this method or that method? We can calculate in percentage, maybe, or in energy. Yeah. And then we validate our calculation data with Hans rule. That will be our second objective. Because our second objective is validate our calculation data with Hans rule. So actually, we take the what to call this, the easiest analysis method, that is comparison analysis. So what we do is we identify the similarities and also the difference. So like among 3 basis set, what is the difference and what is the similarities? And then finally, we can draw an insight. So for example, the size of basis set, what will be the effect of the size of basis set in terms of accuracy? Yeah. Jadi di sini kita bisa menganalisis. Yang pertama menganalisis data kita, antar data kita untuk mempengaruhi efek sesuatu terhadap sesuatu. Semisal perubahan basis set atau efek perubahan exchange correlation. Kemudian yang kedua, kita pengen membandingkan akurasi dari setiap metode. Kan kalau kita butuh mengekstrak data akurasi, berarti kita butuh membandingkan dengan hasil eksperimen. Dan juga kita mengecek seberapa bagus metode yang kita pakai. Terus yang ketiga, ini kaitannya dengan tujuan yang kedua, kita harus memvalidasi data kalkulasi kita dengan Hans rule. Okay. From here, is there any question? No? Okay. About the UNSUT and UTM? Is it clear enough?
Yeah,
It is clear for students from UNSUT, Dr. Farah.
Okay, thank you. I will continue. So this would be the conclusions. At first, our objective. So conclusion is answering the objective. So we have 2 objectives. So that's why we will have 2 conclusions. The first objective will be distinguish the physical and computational problem. So you have to define which one is physical problem and which one is the computational problem. For physical problem, so it's related with the physical phenomena. For example, in module A1, we have to know, do the calculated electron configuration in line with Hans rule? You need to check. So in the exercise 4 or exercise 3, you need to tabulate to visualize the atomic orbital, and you check if Hans rule say that should be S orbital or it should be D orbital, you have to check. When you calculate and then you visualize, is it S orbital as the Hans rule said or not? And then how many electrons that filling the orbital? And then you also can check the energy. Why we need to check the energy? Because we want to know about the level of energy. So maybe it is in the Hans rule and in your calculation, it will be S orbital and then P orbital and then D orbital. But sometimes D first and then S orbital, or S orbital first and then D orbital. So how to check it? Which one is the first? So you have to check the level of energy. So if S orbital is the lowest in energy and then D orbital is the higher, so the configuration will be S first and then D. And then you check on the Hans rule. Is it true? Or we have to change it, like D first and then S. So there is a 3 point. The first is energy, and then the second is the shape of the orbitals. And then the third one, you have to check about the configuration in the Hans rule. That is one example of physical problem. Yeah, I know when you calculate when you doing the exercise in module A1, you will get a lot of problem because this is your first experience. But just list all of your problem, but please not your private problems. Just stick into the module A1. Then you list all of them, and then you distinguish which one is the physical, which one is computation. Okay. And then the second problem is a computational problem. So it's related to technique, tools, and then resources. So for example, which method is the most optimal based on the job CPU time? So this is that you can get this problem when you analyze the exercise 6 or 5. 5, exercise 5 about job CPU time. Or maybe if you compare like your calculation with your friends, maybe the job CPU time will be different because you use like a different laptop, and every laptop has their own spec or specifications. So that will be the computational problems. Or maybe you got the errors, maybe or extra, but you can analyze. So this is the computational problem or human error. Yeah. So just distinguish. So just list all of your problem that you get, and then identify this is a physical, this is a computational. And then the second objective would be check the validity of DFT calculation with the Hans rules. So we have learned how to check the validity of our calculation. So we check whether is it DFT good enough, or this is DFT is good, but there is several outliers that cannot be calculated with DFT. So that's how we analyze or we check the validity of DFT. Because Dr. Fabian said that, okay, DFT is good for many electron systems. But we, as a academician, we need to check first. We cannot just believe, but we have to check it first. So we calculate from hydrogens, because hydrogen only have 1 electrons. And then we increase our system to helium. And then we increase. And then maybe for another module, we will calculate the molecules. And then after that, we will calculate the reactions. Yeah. But before we do the bigger system, we need to check, can DFT calculate the atomic? And the module A1 is a good exercise to do that. Ya, jadi kesimpulannya, biasanya kesimpulan itu memang menjawab tujuan. Jadi kalau kesimpulannya, kalau tujuannya itu ada 2, kesimpulan juga ada 2. Tujuan yang pertama adalah membedakan mana problem fisis, mana problem komputasi. Jadi jawabannya adalah, atau di kesimpulannya kita akan menemukan ada masalah fisis. Nah, problem fisisnya apa aja? Itu kaitannya dengan physical fenomena. Atau kalau yang analogi dengan mobil tadi, itu kaitannya dengan rules. Jadi ada aturan-aturan di fisika, ada hukum-hukum di fisika. Nah, dia berlaku nggak? Yang kita cek adalah elektron konfigurasi yang dihasilkan dari kalkulasi DFT itu apakah sesuai dengan aturan Hund. Itu yang pertama kali kita cek. Nah, kalau dia bisa berlaku untuk atom, kita tingkatkan lagi apakah dia bisa untuk atom dengan banyak elektron, kemudian molekul dan seterusnya. Jadi kita harus ngeceknya dari sistem yang paling sederhana. Terus kemudian kalau yang masalah komputasi itu ada kaitannya dengan alat yang kita pakai atau teknik yang kita lakukan atau resource. Ya, misal laptop seseorang itu kan berbeda. Jadi kita lihat apakah hasilnya sama atau berbeda. Apakah kalian temukan kalau kalian kalkulasi dengan laptop berbeda, energinya berbeda nggak? Kemarin cycle-nya beda nggak? Terus job CPU time-nya beda nggak? Harusnya kalau job CPU time mungkin berbeda gitu. Karena laptop punya spesifikasi yang beda-beda. Kemudian yang tujuan yang kedua, kita mengecek validitas dari kalkulasi DFT dengan menggunakan aturan Hund. Dan di exercise 4 kita sudah belajar bagaimana cara mengeceknya. Jadi kita mengkalkulasi banyak atom dari helium sampai vanadium. Ya. Terus habis itu kita lihat visualisasi orbitalnya, kita lihat urutan energi orbitalnya. Nah, itu apakah sesuai dengan konfigurasi yang diberikan oleh Hans rule. Yeah. Maybe that's all. Is there any questions about the module A1? Yeah, you can ask any questions.
There is no question from Unsud students, Dr. Vera.
Yeah, okay. Okay. Itara? No? Okay.
Yeah, Dr. Vera, just want
Yeah.
to confirm with you about the grouping. Is it confirmed the group members within their own group, or is there any other changes?
I think there will be any changes because, yeah,
They are fixed, right?
we should ask Nabila Sang. Nabila,
Yes, Dr. Vera.
is there any changes in group?
I haven't checked it, and I just received the student ID for the UTM students. I'm going to send it to group after this.
Okay.
Maybe before we start with the group work, we can recheck again. So if there are any groups that need to be combined, then we can do it later. What do you think? Because many students from Unsud also, they withdraw from this class.
And also, we will have to mention to them the deadline for the submission for the modules.
Yes, yes. Oh, how about we announce about the deadline after discussing about module A2?
Okay, that should be fine.
All right. Okay.
Maybe we give the students like a 5 minutes break. Is it okay?
Yeah. Okay.
Yes. Okay.
For
It's
how
5
minutes?
minutes break, and then we continue with module A2.
All right.
So we will start again at 10:55 Indonesian time or 11:55 Malaysian time.
Yes, please.
All right. So after you hear the summary made by Dr. Vera about module A1, now let us continue to discuss about module A2. So I believe Dr. Mark and Dr. Vera has distributed the module to the students for module A2.
Yes, we have. I have.
Okay. So I will share my screen showing you the question in module A2 that you have to work on it. Okay, so this is module A2. The title of module A2 is Hydrogen Atomic Orbitals. This is the project description. This is what you have to work on. Okay, let's read the question together. Perform energy calculation for hydrogen, helium, carbon, oxygen, barium, and zinc atoms with variation of Hartree-Fock and B3LYP, both with restricted method. So you have known about restricted method before. Now you have to use that method again for this calculation. And this time you have to perform the same type of calculation as Dr. Vera has mentioned before, single point energy calculation. You only need to do energy calculation for 6 atoms, 6 different types of atoms. And beside the variation of method, which is Hartree-Fock and B3LYP, you also need to vary the basis set. There are 4 variations: 321G, 631G, 321G asterisk, and 631G DP. You can check the availability of this basis set in your Gauss view later on. Next, add pop equals full and GF input options. I think these 2 options you haven't done it before, but this time you have to add these options as well in your input file. Your task is to perform comparison analysis. Now, Dr. Vera has explained to you before about comparison analysis. When we do the comparison analysis, it means we find the similarity and differences between several things, between two or more things. We still use the same method of analysis, using comparison analysis. And after you make your analysis, draw conclusion from the following tabulations and visualizations. So you don't just stop in analyzing, but you also need to draw conclusion based on your analysis. Now, for results and discussion, these are the things that you have to do. First, you need to tabulate the number of SCF cycles and job CPU time. For job CPU time, you have known how to find it before. You find it in the output file. It is the same for SCF cycles. You can find this information in your output file as well. Second, tabulation of the ground state energy. I believe all of you have mastered this type of tabulation because we have done it before in module A1. And next, tabulation of atomic orbitals and its energy. Okay, for the convenience, we suggest that for the tabulation of energy, you make it in electron volt. So the value that you take from your output file, the unit is still in Hartree. But in performing the tabulation, please convert it to electron volt. And number 4, visualization of atomic orbital with 2 different isosurface value. You have learned how to visualize before, but this time you have to visualize using 2 different types of isosurface. And then draw the conclusion. There are 2 conclusions that you have to make. First, identify which ones are the physical problem and which ones are the computational problem from all the results and discussions that you have done in question number 1 up to 4. The physical problem, which one are is the physical problem, and which one is the computational problem. Dr. Vera has introduced it to you before. And second conclusion, verify if DFT can predict the hydrogen atomic ground state as it was predicted by time-independent Schrödinger equation. Now, about the time-independent Schrödinger equation, Dr. Febrian has ever mentioned it in the previous class. I hope you still remember about it. Okay, so those are the things that you have to do in module 2, and you will work in group. We will give you 50 minutes to work on this problem. Now it's 11:02 or 12:02 in Malaysian time. So the group discussion will be up to 11:50. So in the end, we still have 10 minutes for question and answer and for the closing ceremony. So the group work, you will do the group work up to 11:50 in Indonesian time or 12:50 in Malaysian time. And then the deadline for, should we announce the deadline now? It will, Dr. Mark and Dr. Vera. The deadline for both.
Yes, we're supposed to announce it to them. I've just announced it to my students. So because we have different calendars for our academic calendars for different universities, so we have set the deadline so that everyone can submit it on the same time. So for our first module A1, the deadline will be on the 7th of December, all right, on a Saturday. And for module 2, it will be, for the module A2, the deadline will be on the 14th of December, the following week on Saturday. And module A3, the deadline will be on the 21st Saturday of the following week. And the final module, Module A4, the deadline will be on 28th of December. And you have to upload both at the e-learning at UTM as well as at Unair. All right. With the cover letter that I've given through the e-learning in UTM. So they will upload that same report for both sites. Right.
All right. Thank you, Dr. Mark. So the deadline will apply for UTM, UNER, ITERA, and UNSUD.
Yes.
Okay. So since this is a group work, so they only have to submit one work per group. So you don't need to submit individually, but you submit as a group. So only one student submit as the representative of the group. You can submit for UTM students, you can submit in UTM and UNER e-learning system. But for ITERA and UNSUD, you can submit it in UNER e-learning system. And then, okay, so after this, please, we have made the breakout room for group discussion. Please join the breakout room. And while you discuss about this module A2, please also take picture. The picture will be the proof that you really discuss when we send you guys into the breakout room. And please also attach the picture in the answer for each module. So it is a proof that you really discuss about this module. Okay, so let's start. You can start to join your group. And Nabila San, maybe you can arrange if there are any groups that only have 1 or 2 students, we can combine it.
Yes, Super Lucia, I can.
Yeah. Okay, you can start entering the breakout room now for the group discussions. We will the group discussion session is up to 11:50 for Indonesian time or 12:50 for Malaysian time. Okay. How about in UTM, Dr. Mark? Today, are there any questions from your students?
I think there's no questions on the module. Just the for the ID, I think they want to access the e-learning at Udayan. What do you call it? Is it e-learning? Do you call it e-learning?
E-learning system, yes.
Yeah, e-learning system. So yeah. So when will they get the ID? Soon, right?
I think Nabila has sent it.
Send the file to Parma group.
Okay.
And if there
want to share with me, I will share with them.
If there's any problem, just
it is in the group. Nabila has sent it to you in the group, Dr. Mark.
In the
ID for in the Telegram group.
Oh, okay. All right. I'll send it to them.
All right.
Well, what about the instructions to access? Is it everything?
Oh, yes. I will put the website on the chat.
Boleh diam sikit. Saya tak dengar. Yes? Sorry?
I will put the website on the chat since I'm a little bit worried the last time they're not able to access.
Okay. All right. Thanks.
Please provide also with the clear instructions to access the website, Nabila.
Yes, I will provide.
Yeah. Thank you, Nabila. Okay. How about,
Thank you.
thank you, Dr. Mark. How about students from UTM, Dr. Vera? I mean,
Yeah.
Itera.
Is there any question for module A1? So, no? Okay, so you ready to submit?
Wow, the spirit is so high.
Okay, question for module A1.
Okay, thank you, Dr. Vera. How about you guys from Unsud? Do you have questions? Ada pertanyaan? Aman? Everything okay? Okay. Since everything is okay, let us take picture before we end the class today. Please open all your camera, guys. Nabila, please.
Yes, I will take the picture again. Please turn on the camera and please change the display name to be student's ID.
Kalian boleh buka lah kamera, your camera. Oops.
Please change the display name according to the format that I've sent on the message on the group chat. Okay, ready? 1, 2. Eka Nabila Tari, please put your. I cannot see your full face. Yeah, only your forehead, I guess, half of your face. Okay, let's take a picture. 1, 2, 3. Wait a moment. In a moment. Okay, one more. 1, 2, 3.
All right, thank you, Nabila. So let us close this class with a closing prayer. Dr. Vera, please help.
Bismillahirrahmanirrahim. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Rabbana taqabbal minna innaka antas samiul alim wa tub alaina innaka antat tawwabur rahim. Amin.
Thank you very much, Dr. Mark, Dr. Vera. Thank you very much, guys. See you next week. Bye.
Thank you, Dr. Vera. Thank you, Nabila. Thank you, Sida.
Thank you, Dr. Mark, Dr.
Thank you.
Vera, Dr.
Thank you, everyone.
Lydia.